Hello, everyone, and welcome to this final panel session of Beyond Bohm, Science, Art and Creativity, Physics and Metaphysics. I'm James Barbieri, Associate Program Director of the Party Center, and I will be your host for today. With me today hosting, we have Jenna Axelrod, Associate Director of the Party Center, who will mediate the panel discussion. As hosts, we are here to help you throughout the call, so any problems, just feel free to just drop us a message in the chat. Before I begin, I'd just like to very briefly go through a couple of Zoom rules for today. First of all, if you could please turn off your microphone during the presentations and discussion, just to ensure a good quality audio, that would be great. But at the same time, encourage everyone to turn on their cameras, just to create a nice, inclusive education environment by seeing everyone's faces. During the second part of the session, the Q&A and discussion, you can ask a question by either using the raise your hand function, which is at the bottom of your screen under the reactions, or you can physically raise your hand, and if I spot you, you can ask your question. Otherwise, you can write your question in the chat. I encourage you all to, even during the first part, to write your questions in the chat so we can select the ones to ask in the second part. And yes, finally, all sessions are recorded for archival purposes and for you all. The recording will be uploaded to Vimeo in a few days, 3 days after this session, so you should all receive the link to get this. Now, we can begin. Today, we are honored to have a great panel to discuss the different topics that have risen in the first part of Beyond Bohm, Physics and Metaphysics. So on today's panel, we have Emily Adlam, who opened this series with her presentation on contextuality in the de Broglie-Bohm and beyond. We have Basil Hiley, who presented last week on the Dirac-Bohm picture, Bohm's 1952 approach in a wider context. We have a newcomer, Dave Schrum, a good friend of David Bohm, and the Pete family, who will act as a bridge between this part of the Beyond Bohm series and the next, which will concentrate on contemplation and creativity. And of course, we have Shantena Sabbadini, chair of the Beyond Bohm series and director of the Party Center. And with that, I'll pass it over to our other host, Jenna. Welcome.
Thank you, James. Thank you all for being here. Thank you, panelists. Those of you who have already presented, fascinating stuff. And I'm looking forward to today. So the first question is for any of you or all of you. And it's about what is Bohm's relevance in today's scientific world? Do you want me to call you out, or will you behave yourselves?
We'll behave ourselves, I hope.
I don't believe you, Basil.
No, I know, but never mind. Let's have a go. Actually, I think now that I'm seeing what is going on in the literature at the moment, I think Bohm's views are beginning to get discussed. Still not amongst the hard-lined physicists, because they don't feel there's anything to be gained by that. Although I must admit, I did talk to Roger Penrose about David Bohm's more philosophical ideas about the implicate order. And he said, sorry, Basil, I just don't get it. I don't see the relevance of it for what we're doing. He is dealing with consciousness. I think, in fact, he's in a conference at the moment, his 90th birthday celebrations. There's a whole series of lectures going on at the moment. So I think that's the problem. Those people who do get it are extremely interested, but there's not many of them. I've actually come across a couple of young professors at UCL, and they are actually picking my brains like mad. So I'm hoping I say the right things and we come to the right conclusions. One of them is an expert in dark matter, and he feels there might be something, and this is a very big might, in what David is saying in this regard.
Wow.
So I think that's really the latest that I would say. Anybody else want to say anything? Otherwise, I'd like to continue with my discoveries, because after I closed down last I discovered.
We have questions coming up.
Okay, let's.
Oh, go ahead. Sorry. What did you discover?
You've got to discipline me, Anna.
She said you were not going to behave.
Thank you. Thank you. We're on record. Okay,
I will
so
add a small comment. Yeah, I think one of the big changes that Bohm's thinking has brought about is we don't necessarily need to be fixed on an ontology, and I think Bohm showed us that you can give like different maps, different models, and that they are all, if well constructed, they will all work. So I think it's an invitation to go beyond, certainly going beyond our fixed ideas of particles and waves, and it's like it seems to me like Bohm's work started from trying to recover a particle wave picture, an intuitive picture of reality. But he moved then way beyond that. And the notion of implicate order, if I understand it correctly, goes beyond the notion of particles altogether. Isn't that so, Basil?
Yes, absolutely so. And in fact, it's actually in the very nature of quantum mechanics itself. I'm sorry I bored you last time with this Stern-von Neumann theorem. And what that already shows is there is no unique mathematical description.
Right.
You can have unitary transformations which take you to a new form of description which are mathematically equivalent. And the interesting debate is, are they physically equivalent or are they telling us something different? But what I never touched actually was that the Stern-von Neumann theorem doesn't hold for infinite degrees of freedom, i.e. the field theories that Giuseppe Vitiello was talking about. And there you have inequivalent vacuum states, you have inequivalent representations, and that was the new structure that he was trying to exploit and Isaac was also trying to exploit. So that in a way is going beyond Bohm.
Right, right. So that seems to me like very significant, philosophically speaking.
Well, it's something we ought to realize, you see, and I think I think also I tried to say some time ago to the a selection of you Pari people that we need ambiguity, otherwise nothing will move. Mm-hmm. You know, going back to Zeno's paradox, for example, the arrow. How can it be at a point in space-time and yet have a momentum? Mm-hmm. And we've always thought that we've understood that by means of the infinitesimal calculus. That means everything, a trajectory is everywhere continuous. Mm-hmm. It ain't so in quantum mechanics. It doesn't work. The trajectories are continuous, but they're nowhere differentiable. And that is the thing which gives us the headache, because we cannot apply our classical ideas to quantum mechanics.
And we are not even sure that space and time are continuous.
Indeed, I mean, half of the battle, it's been going on for a long time, is what is the nature of the continuum? That has been a question which a lot of field theorists don't see the significance of, or at least don't think it's significant, and yet they base all their field theory on the space-time manifold, on the continuum.
Yes, yeah, and is the continuum continuous, actually, you know? And so what we've talked about for a bit is forms which are, in the end, mathematically equivalent. and they give us perspectives, different viewpoints. And I think that's really valuable. I think one would call them perhaps different art forms. But I think even more interesting is when we have viewpoints which are in absolute contradiction with one another. And when they're in absolute contradiction, the way we tend to think, the way we're cultured to think is, this is right and this is wrong, or this is right and this is wrong, or they're both right and they're both wrong. And what Bohm seemed to be capable of doing is holding the tension between the two of them, not in the sense of waffling, but in being able to believe that they're both right, they're both wrong, this is right and that's right and this is wrong, all at the same time, to hold simultaneously contradictory realities. And this is incredibly important, I think, in our own inner exploration and in the scientific exploration, to be able to do that, because otherwise, how can we be kicked out of our context? You see, the whole problem, say, I've done limited scientific research. I went in another direction, but to research something, I research it within my framework of thinking, my box, my knowledge of physics, my technical expertise, and so on. And I try and build the box a little bigger. But this whole, this Bohm approach to it, of holding the tension between contraries, between opposites, being able to hold contradictory points of view, it allows the brain to kick into a different space where it is not dependent on its own framework entirely. So I think that's really interesting as well, then, as having equivalent views, holding the tension between views which are entirely in contradiction.
It's pure Chuang too, what you're talking about, Dave.
What did you, I'm sorry, Shantena, I think I stepped on you. What did you say?
That what Dave was just telling us is pure Chuang too, almost literally.
That's beautiful. Emily, did you want to weigh in on this? I have a question that seems pertinent, ready for you, or you can join this particular one if you wish.
Oh yeah, with regard to Bohm's significance for modern science, I think definitely in my own field of the interpretation of quantum mechanics, Bohm's ideas are gaining increasing prominence, and I think among one of the options that is taken the most seriously. And I think for me, the thing that's particularly interesting about the de Broglie-Bohm approach is that it's, as far as I know, really the only interpretation which makes concrete new predictions. And so it's really the only interpretation which at the moment seems to have some hope of being verified or falsified one day. So that's kind of a really exciting area for the field of the interpretation of quantum mechanics, in that it demonstrates that there is hope to obtain predictions and draw some conclusions about this kind of topic.
That is very interesting. I mean, I can see that, I can anticipate that Basil would like to chime in, but first I'd like to ask Emily another question, if you don't mind.
Yeah.
You gave a wonderful presentation, and so please forgive me, because this is a very base thing to do here. But in very simple terms, would you mind defining contextuality for us? And then, if possible, to just simply distinguish the difference in Bohm versus standard mechanics.
Yes, so sort of part of the thrust of my talk was that it's quite hard to define contextuality. But broadly speaking, we talk about there being contextuality in situations where we have processes in quantum mechanics which look the same at an operational level, sort of in terms of the operational statistics, but which can't be represented in the same way at the level of an underlying ontological model. So we have a kind of asymmetry in the underlying ontological stuff, which doesn't appear to be reflected in the statistics. And the question is, why does that come about? And how is it that the differences on an ontological level manage to kind of exactly cancel out so that we can't see them at the operational level? And the comment I made with respect to de Broglie-Bohm in this regard is that the de Broglie-Bohm approach offers quite a nice way of understanding how this kind of special fine-tuned effect can come about, because de Broglie-Bohm, in at least some versions of it, has this account where we start out with the de Broglie particles away from their usual distribution, and they evolve slowly towards it over the course of history due to the properties of the evolution equation. So the de Broglie-Bohm account provides a kind of quite natural seeming description of how this sort of special fine-tuning can occur, and very few of the other interpretations have any sort of substantial account of how this fine-tuning contextual effect can come about.
That is wonderful. Now, I have a question for Basil, but I feel like perhaps you don't need one. Do you have a comment right at the ready?
No, I know that Emily is talking about the ideas that Valentini has.
Yes.
And I'm very much interested in if they find something new there. That's very important to continue. I don't think they will, but I don't want to be an old pessimist. I want them to carry on with their enthusiasm and see if there really is something new there.
I mean, they may well not find anything, but I think this is a really nice example of the fact that interpretations of quantum mechanics don't necessarily have to be totally empirically equivalent. There is at least some hope of finding some special cases which would be evidence for your interpretation.
That's great.
We've got agreement there, Jenna, so don't worry.
I thought I was mediating a fight. I misunderstood.
No.
Well, let's see.
Not yet.
Not yet. Okay. Well, yeah, we saved the controversial questions toward the end. So, Shantena, I have one for you that Steve Dice had emailed in, and I see you. I think you mentioned it in the chat also here, Steve. So, Shantena, I'm going to read Steve's question to you. Okay. If stuff is neither particle nor wave, but rather a localized process of what looked like field oscillation, then how does one explain non-local effects? How can these little blobs affect each other over long distances, though admittedly when such distances are based upon emergent space-time? Boom.
You put manners in it.
Steve, well, yeah. What a good question. I think what we are pushed towards is an understanding that any description that makes sense is necessarily non-local. It's like there's just one universe, and as we said in a couple of different ways, a model of reality based on particles or whatever thing is just a model. We have different models of reality we can compare. But the notion of concrete localized objects, we've lost that through Bell's theorem and aspects experiments already 40 years ago. So it's like since 40 years, we know that essentially the world is not local. Or it cannot be simultaneously realistic and local. And what Bohm showed is that if you give up enough the locality, you can recover some element of realism, but that's probably not ultimately so at a deeper level. So yeah, I think locality is like an old habit that we're going to have to let go of.
I enjoy that answer. Does anyone on the panel wish to fight Shantena about that answer?
No, I won't fight him about it. I would rather confess and say I have no idea how non-locality comes into it. We have to face it. I mean, look at the experiments that were done by Zeilinger and his collaborators. Over 143 kilometers, this non-local effect exists, provided there is no dust storm in the Sahara Desert. If there's, because it's done between two islands in the, oh God, what's his name? I can't say it, Balearics? No, how do you pronounce that word? Where the islands of...
Baltic?
The Balkans?
No, down at Tenerife. What is Tenerife?
Oh, the Canary Islands.
Yes, right in the Canary Islands, in that area. And they've got another name as well. But he fires photons and does the measurements on 2 islands, which are 143 kilometers apart. So that whatever this is, it's very subtle, but it's also very fragile, because once you have anything which disrupts it, the whole thing collapses into, these are called entangled states.
Mm.
And an ordinary dust particle in the atmosphere can disentangle these two photons that Anton was firing across the ocean. In fact, I'm just wondering, can I show what quantum mechanics actually predicts? A lovely little picture that I think helped me quite a lot. And that is Chris Dewdney's showing how the 2 particles change their spin as you move them apart. Is that okay? Can I show you though? They're just pictures.
Yeah.
Right, can I get the screen? Am I allowed to share the screen?
You're a co-host. You should be able to, yeah?
Yeah, okay. Okay, can you see it?
Yeah.
Okay. Now, what I want to do is actually to, oh, is it working?
It is.
Yeah.
Okay, good. Now, I talked about the Stern-Gerlach experiment myself, and I probably did it rather quickly because I wanted to show this beautiful photograph. Now, the Stern-Gerlach, for those people who are not familiar with it, is you've got a whole series of atoms with just spin a half, and they come through an inhomogeneous magnetic field, and it splits the beam into 2, either spin up or spin down. And when we explored it through the Bohm interpretation, what we found was that here is the end of the inhomogeneous magnet. That corresponds to that there. And what we see is that the spins actually haven't reached their final position of up until quite a significant distance away from the magnet. So already something non-local is happening here, because there's no magnetic fields here at all. In fact, the only non-zero thing here is the quantum potential. Okay, now let's go one stage further. Now, it worked beautifully just now. Now it stopped working. Never mind. Let me go on to this picture. And this is Stern-Gerlach 1, Stern-Gerlach 2. And you can make this distance as far as you like. You can put this on Tenerife and this on one of the other islands in the Canary set. And what you find is, if there's no magnetic field on there, but a magnetic field on here, that's miles away, you find not only the spin forming here and deflecting the beam, the spin also forms on the other particle, so that when they start, they don't have individual spin up or spin down. They're in a 0 spin state. But as soon as you mess around with them with this magnet, the other one, although it's miles away, will respond. And that's a calculation from the 2-body Schrödinger equation using the Bohm-de Bruijn model. So there you see something is happening. Now, the question is...
Sorry, Basil, is that the same particle going through both magnets?
Yeah, this is one particle. This is one particle pair, another particle pair, another particle pair, another and so on. but this is the pair that are entangled. This is another pair that are entangled.
Yeah.
Another pair that are entangled. And it just shows you, it depends where they are as to what happens.
Thank you.
And if you go back to, if you go back to the picture that I showed here, you see this is the forming, so that when the Stern-Gerlach magnet on the far magnet is switched on, the spin starts turning, but the trajectories don't get deflected. It's a remarkable result. And this is what we have to try to understand. Now, a lot of people say, yeah, but you ain't got the relativistic theory in there, and therefore, but what Bob Callaghan and I did was to calculate, was to show how the Dirac equation could be treated in exactly the same way as the Bohm-de Broglie model for the Schrödinger particle be treated, and we get a quantum potential for that, and it's a scalar, so that it's not affected by this kind of behavior. And if you follow up from what the information that I got from Roger Penrose, is that when you look at gravity, you cannot localize energy in general relativity. It is basically a non-local idea. So we've got to get rid of this idea that energy is only local. Energy is something which it can go beyond locality in space and time. And I think that's the non-locality that we have to really work hard at to try to understand in a metaphysical sense, if you like. It's there.
Let me see if I understand you, Basil. The non-locality in general relativity is due to the fact that the deformation of space-time, let's say, is acting all at once on the whole situation.
Yes. Shall I go on?
Yes,
I'm grinning, so I know an answer. Okay. Now then, I go to this discovery I made 2 days ago. No, the weekend, last weekend, after coming off being inspired by the questions that I was asked at my presentation. And I was talking to my friend Glenn Dennis, and he said, look, there's this paper by Bryce DeWitt that you keep twittering on about. Have you got a copy of it? And I said, no, I haven't actually. I think we ought to get one and have a look at it. And we had a look at it. And you'll never believe it was published in exactly the same volume as Phys Rev that David Bohm's paper was published. Not in issue 2, but in issue 4. And what that does is show how when you consider a curved space-time, you find that the Bohm factor, the amplitude of the wave function turns out to be the scalar curvature in this story. And Bryce DeWitt has the quantum potential in it, left, right, and center. And in fact, if I might just, I did prepare this. There's the equation. Oh, have I got it here? It's in volume 4 of Phys Rev 85, whereas Bohm was in volume 2 of 85. And look what he says. This equation is what DeWitt writes down. It's a thorough Phys Rev passing the referee's paper. So it's not just sleight of hand. It is the quantity that must be added to the covariant classical Hamiltonian in order to produce a covariant quantum Hamiltonian. There it is. the quantum potential. And it's exactly the Bohm quantum potential. And look what he says in conclusion. The quantum mechanical potential, he always puts it in scare quotes, as if he's talking about something he shouldn't be, is seen to be strongly divergent, a strongly divergent quantity in the present case. It must be, sorry, I can't, oh, it must nevertheless be retained in all quantum expressions in order that the Hamiltonian operator be invariant under change of variables used to describe the gravitational field. In fact, it's quite general. The example comes out of when he was treating the gravitational field. So you see, Shantena, it's the curved space-time. It's not necessarily the gravitational field. So we're now saying, what the hell is this gravitational field? How do we link it up with quantum mechanics? And look, 1952. And then silence. I just don't understand why the silence.
I'm going to jump in and unsilent things. You move your gobbledygook out of the way.
Oh, sorry. Yeah. I love the way you, all this hard work I do to show you new insights.
You know, and I always look at your slides and think, it's really gonna gel this time. And I'm like, I guess I need new glasses. I have a really basic question for you, Basil, which I feel you shout out 52, and so you led me right to it, which is, how does the idea of the implicate order arise from Bohm's 52 paper?
It arises in a very interesting way. It arises, first of all, by denying that the Bohm-de Broglie theory is adequate. Sorry, Emily, this is what Bohm says, is adequate. He then goes through and shows that, or argues in one whole chapter of the book, this is Chance and Causality I'm quoting from. And what he there shows is that we have to go beyond mechanism. We have to go beyond mechanics. But already in his 1952 book, Quantum Theory, which was an attempt to present Bohr's idea, you know the story, he was asked to give a lecture at Princeton on quantum mechanics for undergraduates. And he gave this lecture. And at the end of it, he said, I don't understand this. So I'm going to write a book. And of course, the best way to understand something, according to him, is you write a book about it. And this was the quantum theory that appeared in 1951. And in there, when he's discussing, if you like, the metaphysical consequences of quantum theory, very, very interesting chapter. You should read it if people are interested in that kind of thing. And you'll find he said, as a footnote, I think the term quantum mechanics is a misnomer. It should be called quantum non-mechanics. So already the idea was forming in 51. But the interesting thing is the last chapter in that book says hidden variables are not possible and gives an argument about non-locality, saying why they're not possible. And then in 52, I mean, the book was probably a bit earlier than 51. That's when it appeared in print. But in 52, after having a discussion with Einstein, he then produced this 1952 paper, and that's why he put in the words hidden variable and showed that a hidden variable theory was possible, but it was non-local. So he was actually explaining the EPR paradox, but in a way that Einstein screamed, no, no, no. I do not believe in spooky action at a distance. But it's there. Bell's inequality, as you said, Shantena, shows it's there. Experiments have been done, many experiments now. I'd like to just mention David Butt, who was with me as a reader, who set up the very first experiment to see whether this non-locality still existed over space-like separated events. And we got a result, yes, 23 meters we had a record at one stage. But then Aspect came along and did a much better, more refined experiment. And you know the history, ending up with Anton. So it's there. Now the question is, how do we understand it?
And where is there? Emily, did you want to respond to Basil's trash talk?
Well, I mean, I agree with Bohm and Basil on this point that the de Broglie-Bohm interpretation is not yet complete and is perhaps too mechanistic in its worldview. I think nonetheless it has some really interesting insights. The idea that you can have some kind of classical reality which is guided by a wave function in some sense is I think really powerful and is definitely I think a thing that will ultimately appear in whatever succeeds it. And I think I really like the idea of the equilibration process where we have the quantum distribution being reached in a natural evolution process over time. And so I think that although I agree that this picture is perhaps too mechanistic and classical, it's still got really important insights contained within it that I think will shape the future of the interpretation of quantum mechanics.
Okay, good. I hope you're right, because what I'm doing, Emily, is actually destroying the Bohm-de Broglie theory in a way, and I don't really want to do it. I've spent all my life trying to defend what I started with doing with David Bohm and Roger Penrose, which was trying to develop a mathematics of structure process, as David called it in those early days. And yet at the same time, discovering that the Bohm-de Broglie theory didn't have the faults that I was led to believe it had. Can I tell you, I was in the library in the physics library in King's College, and I was reading Bohm's and de Broglie's double solution. And my then supervisor, no, my second supervisor, I won't name him, came up to me and said, "What are you doing?" Because I was supposed to be doing a PhD on solid state physics. I shouldn't have been messing with quantum. He picked the book up, looked at it, turned it over and said, "You shouldn't be reading that. Don't waste your time. Close the book up and put it back on the shelves again." Can you imagine an intellectual, a very, very clever person who missed the Nobel Prize by, a hair's breadth, did that to me? Can you imagine what I then did? I went back.
I'm sure you went to
and I took the book off and I read it with even more enthusiasm. Anyway, sorry, that's you see, and then you see, so Emily, great. I'm glad you guys are doing this. It's important. It should be done.
Yeah.
But I'm straying ahead. Not very successfully.
Well, I'd like then to ask a question to both of you. It's like very down to earth, naive question. It's like it's let's say Bohm 1952. You start by taking apart the Schrödinger equation, separating the real and imaginary part, and build the whole theory on that. How can we hope to see something different from an experiment when it's that one equation taken apart?
Okay, Emily, do you want to answer that? I can answer it.
I can answer. Yeah.
Okay,
so
you answer it. They don't want to hear me anymore.
The de Broglie-Bohm theory, you're right, doesn't make different predictions for sort of present day experiments, as far as I'm aware. But what it does, at least some versions of it do make some different predictions with respect to cosmology, because basically the idea is that the de Broglie-Bohm theory requires that the particles at the beginning of an experiment are distributed in space-time according to the wave function mod-squared amplitude distribution. And so some people working in that field, like Valentini, have hypothesized that at the start of time, the particles may not have been in that distribution and have ended up in that distribution by evolving according to the wave function evolution equation over time. And if that's correct, then we'd expect that some effects in the early universe would have looked different from what we would naturally expect from standard quantum mechanics. And we might be able to see some signatures of that in cosmological features like the cosmic microwave background radiation. So the hope is that by looking for those signatures of non-quantum behavior in the early universe, we could gain some confirmation of the de Broglie approach.
Thank you.
Okay, good. That's nice. Can I now put in a second?
Right.
Yeah, no, can I?
Yeah, of course. We all want to know what you just got.
Now, I went to take off my shelves a paper that David and I wrote in 1989 called Non-locality and Locality in the Stochastic Interpretation of Quantum Mechanics. And in there, we proved a theorem, I hope it's a proof, which says that the equilibrium will come about very quickly indeed. And I think someone estimated that it would be 10 to the minus 53 seconds. It would be making reasonable assumptions. So, Emily, that's one of the reasons why I am not enthusiastic, but please, the theorem may well be incorrect. And
well, also, I think timescales work a bit differently in the early universe. So things that happen in the first 10 to the minus 53 seconds can still have a really big impact because everything is happening very quickly at the start of time.
Good,
so
good.
It's possible that one might still see effects even if it is very quick.
Good, good, good. Let's see it.
I enjoy that. Shantena, do you have room in your life for a question about the connection between the implicate order and the notion of the quantum vacuum? Is there a connection? This was emailed from Chiara Zaganel.
Right. That's a very interesting question. I don't think I'm particularly qualified to answer it.
Oh, perfect. We'll move on.
No. I would like to answer it. Of course. Very much so. Can you repeat the actual question so that I've got?
Is there any connection? Is there any relationship between the quantum vacuum, with all its creative activity we know about, and the implicate order and Bohm's implicate order?
Well, I think very much so. But I'd like to again use my friend Roger Penrose to help in this, because I'm in his territory in general relativity, and it's in his territory of dealing with gravitational waves, etc., and the non-locality of energy. And he writes in his book on, I don't know whether many people have seen this, The Physics of the Vacuum. Hope you don't mind me advertising.
Lovely. The philosophy of the vacuum.
The philosophy of the vacuum. Of vacuum, of vacuum. And it's edited by Simon Saunders and Harvey Brown. And it has some essays from some very eminent people. And the one I'm the first one is by Einstein. It's a translation of Einstein's article, Über den Ether, which is an English translation. You see, what I think in my talk, I actually said one of the reasons why the early school dealing with quantum mechanics was not in the current literature because it was all in German. But then I find the Bryce DeWitt, which is in English. So that hypothesis has gone out of the window. But this paper is in German, and that's where he talks about photometry, which is the idea I try to introduce. But then the paper I want to, the quote I want to use is in Penrose, which is the second one on there. And he says, we cannot draw a clear dividing line between what we call matter or substance and what we call empty space, supposedly the void entirely free of matter of any kind. Matter and space are not totally separate entities. Actual substances need not be clearly localized in space. And this comes out of his classical interpretation of nothing to do with quantum mechanics, because he then adds the nebulous and non-local additional features that the quantum theory injects into our picture of the world greatly strengthens this conclusion. So he's actually saying that if we look carefully at gravity, it is non-local in its classical domain.
So perhaps I can just say a brief word about it in a way which is directed to the non-expert. So is there a connection between the quantum vacuum and implicate order? Bohm used to say that a theory of the vacuum is a theory of everything, because vacuum, you know, the pure emptiness, if we put energy into it in the right ways, we can get anything popping out, any kind of particle that there is. And so the vacuum is an incredibly coherent state which contains in potential form all that is. And so yes, there is connection between the vacuum and the implicate order, because what the vacuum looks like is nothing. Therefore, everything that comes out of it is implied by the manifestations that arise. So it's all implicate, it's all implied. It all has to do with unfolding. So that's just speaking of it in a non-technical way.
I love that.
Can I just add one thing? Maxwell defined the ether. Remember Maxwell, it was when Maxwell was developing his electromagnetic theory at the turn of the last century, that that one was assuming that the vacuum was a plenum, was a substance of some kind. Mm-hmm. And what Maxwell said was that a vacuum is what is left after we have taken everything out of it that we know how to take out of it, which I think is a very perceptive definition.
Yeah.
So the vacuum is not empty. And in fact, in quantum mechanics, when you go to the field theory, you have many inequivalent vacuum states. Come on, many inequivalents, nothingness? You gotta be joking. No? And that is proper top line physics. I'm not quoting oddballs. That is the way the high energy physicists look at the vacuum.
Look at the vacuum. Yes. So,
and of course, as I've mentioned before, Bohm was fond of pointing out that if we take a reasonable assumption that the vacuum is a plenum all the way down to the Planck level, which is commonly understood to be, a unification level, that in one little cubic centimeter of vacuum is contained much more effective energy and matter than in the entire visible universe of stars, galaxies, and so on. And when he said much more, if you look into the numbers, it's more than 1 billion, billion, billion times more than everything in the visible universe is there. So that then tends to suggest that everything we see and know, including ourselves, is a very tiny bubble in this immense sea.
I love that. So we will be getting to your questions. We just have a couple more for the panel. We may go a little bit past the top of the hour with the panel, and then we'll be hearing from you all through James. I see you in the chat, everybody, and we are noting your very good questions. But just a couple more from us before we move on. Basil, you had an exchange with Pavo, and you suggested that we drop the expression wave function from the discussion of quantum phenomenon.
Yes.
And so why would you like to make things so difficult and by changing the language?
Yes, that's a very good question, actually. Why the hell should I do that? Well, I don't want to do it because I want to make things simple. You wouldn't believe it, but I like simple things. But unfortunately, the simple things don't work. So what we did with spin, Dave was criticized way back in the 50s. But Dave, your theory doesn't deal with spin. It only deals with a Schrodinger equation. Okay, says David. Then what I'll do is I'll use some Cayley-Klein parameters. Oh, what the hell are they? They happen to be parts of an algebra which I've uttered and people usually shudder when I do, and that's Clifford algebras. Now, it so happens that there was this mathematician, William Kingdom Clifford, and we've seen his gravestone in where Marx's gravestone in Highgate Cemetery. Would you believe it? He's buried there. So he's a Londoner, and he worked in the University College London, where I now work. Okay, so why was he talking about spin? And this was in 1850s to 1870s, 1880s. Because he felt that we'd got our idea of mathematics incorrectly. Mathematics should be about activity, not about numbers. So that he thought, well, and remember, Bohm was going down that route, structure, process, activity. So what did Clifford say about that? Well, he said, you should think about mathematics as how many times is 2 enfolded into 6? And you find it's 3. Or you could ask, how many times is 3 enfolded into 6? You get 2. So there you have different ways of enfolding, but getting the same answer out, the same outcome. But if you go to do rotations, if you rotate about 2 axes perpendicular to each other, the final result depends upon which order you do the rotations. Do the rotation here first, second, you get entirely different outcome doing this first and doing that second. Do it, try it, and you'll see. So mathematics is about ordering. It's about process. It's not about particles flying around trajectories. That's what we interpret it as, but it's about enfolding and unfolding. And so the Clifford mathematics is actually dealing with folding and unfolding in a way which gives us spin of the particle. And that leads us to the quaternions, and the biquaternions, which he knew about, gave us the Dirac theory. So there, in that algebra, we have already, before quantum mechanics came on the scene, we have the mathematics waiting. And that's the mathematics I grabbed to show how we deal with this folding and folding order. And that's what David was saying. How do we enfold and unfold? Okay.
Yeah, thank you for that. You lead me to want to direct a question to Dave Schrum. Hi, Dave. So Bohm calls attention to the way language shapes our perception of reality. And I wondered if you might be able to tell us a little bit about your understanding of the Rio mode verb-based language experiment.
I really understand very little of it because when I was at Birkbeck, it didn't interest me. I mean, I have a few sort of little stories about, you know, say my friend Don Schumacher being in the lavatory at Birkbeck, or not at Birkbeck, at Krishnamurti's place, Brockwood, and hearing Bohm and Krishnamurti talking outside, and hearing Bohm try to bring up the verb Krishnamurtation. So I thought that was a little interesting, but something that you can play with yourself if you want to is with regard to the Rio mode. One was also looking at prefixes and suffixes. So when we're talking about quality of something, you know, I don't know, the greenness, the hotness, and so on. So we can see the function of ness. He said, look at what is nessness? What is nessness? You let yourself sink into that, and you will find it takes you some very interesting places. And then there's, of course, the irreverent student who would ask, you know, well, what is nessness then? And anyhow, I was better at being irreverent than understanding things, I'm afraid. Only in my elder years have I think, really appreciated Bohm fully. You know, I wanted to be right some of the time. So anyhow, so the Rio mode, let me just say a little bit. I don't know a lot about it, but its purpose is to bring us away from thinking in terms of contents to thinking in terms of process. And this is then a different kind of understanding. And you really want to go into Bohm at length, the difference between conceptual or literal understanding, participatory understanding. Participatory understanding is not something that you understand and have understood. It's a movement of understanding in the present. And so, and this was something that Bohm was very keen to try and culture in people and in society in general. He felt that it would bring a transformation. So, but there's a very long story there.
David, can I just chip in quickly? I was exposed to the Rio mode day in and day out at about the time you were talking. About. And in the end, I found what we were doing was making nouns out of the verbs. And it just defeated the whole aim of the thing, because, you know, our life is about lifting up things, lifting up a cup, having a drink of water, and so on. And we don't emphasize the activity. Some languages do, and I think Little Bear is going to talk to the group at some stage, and their language, I think, has features of this in it. But like you, I'm afraid, to me, there's only one language, and that's the language of mathematics. But that is very difficult to get across. I can see Jenna laughing at me.
I'm just seeing your slides in my nightmares.
I hope I don't give people nightmares.
So this is the last question coming from before we move on to the group, and this is for everyone on the panel if they feel like answering. So what do all these scientific and technical discussions have to do with the world that we live in, how we view the world we live in?
David, go on, please.
Oh my God. Well, I think largely they don't penetrate us. if you want, the truth, that they don't penetrate us in a way that moves us out of thinking them in terms of concepts and objects and so on, that we can reason our way through. They don't penetrate us to the extent that they kick us into participatory thought. I mean, I call it sort of Bohm-Einstein thought, which is different from what I call Feynman-Dirac thought, which is based on physical, mathematical understanding and intuition. The Bohm-Einstein kind of thinking is something that tries to kick us out of our framework of thinking. It's not about thought. Thought comes in secondarily. So I have the feeling I'm going to start to amble and ramble now, and I'll open the floor to others to speak.
Shantena, do you want to say anything?
Oh, I think you're still on mute, Shantena.
Okay, probably the most interesting would have been silence, but well, I think that all these intellectual exercises have a useful side, which is, in my opinion, deconstructive. It's like they undo the impression we ordinarily carry that we understand what's going on. We know what the world is made of. We know who we are. I think undoing these certainties is important. And you, Jana, made a film about that.
We are finishing it right now.
So at the same time, I think there are very pressing problems that are waiting for us out there. And unfortunately, this like high level understanding is not particularly helping us to deal with all the other stuff. It's like, and the root problem, in my opinion, is like science is born from an operation of abstracting. It's born from building models of reality, which is a selective choice, which is very important because that's how we can make, you can repeat experiments and compare results and all that stuff. But reality is larger than that. And the part that we cut off when we do just science is absolutely crucial for our life, and for the life of all life on Earth. Yeah.
Beautiful. Basil or Emily, do you guys want to respond to this question? There's no pressure. Otherwise, this group has a lot of questions for you in the queue.
Sure. I think that obviously we live and have to continue living in the classical world. So to some extent, what's going on in the quantum world doesn't strongly affect our lives in the classical world. But I do think thinking about the interpretation of quantum mechanics leads us to some very interesting reflections on time and the nature of it and the way in which we're embedded in it. And I think thinking about those issues does tend to change one's perspective on sort of our lives as agents subject to temporal forces and apparently moving forwards in time. And I think in that sense, thinking about what's going on at this very fundamental level can impact our sense of ourselves as temporal beings.
Beautiful.
You want
And
me
look left to get the last word.
You want me to get the last word?
Please.
There's no such thing as the last word. So for me, it's very simple. David Bohm opened up a door of looking at reality, which is totally different from the world I was taught as a scientist. One of the problems has been that he emphasizes time and time again that the problem is that we always fragment everything. We solve one problem, we isolate it, we solve it, and then, look at me, it causes another problem down the line. So then we have to solve that. And in solving that, we then go down the line and we cause another problem. And therefore, if we can get a different way of, if we can break out of the classical prison we're in, and apply, and we're not in the prison, our thoughts can go everywhere. Our thoughts are free. So why not coming in from the physics that we've got this freedom? I mean, Weil, for example, who I'm a great follower of, he actually followed Fichte. And this was the idea about activity and passivity, about how we understand process evolving around us, thought processes. We cannot put thought into a mechanical model. It just doesn't make sense. And we know from just our introspection how we can see a different type of pattern flowing from that. And my secret hope is that we can understand this not only intuitively, but also mathematically. So that our mathematics is not the mathematics that is taught. I see mathematics mathematics used to be in the arts faculty in the universities. Mathematics, as Grassman says, is not about material process, it's about thought. It's not about the content of thought, but the actual form of thought. And it's that which I hope to convey to people. So I hope they don't get too bogged down in the detail. The details are just reassuring that it's not hogswallop. But the idea is to flow in this new type of thinking. Okay, that's enough. That's my hope.
I have loved this discussion. I need to thank you all. You're not going anywhere, but I am. So Emily, Basil, David, Shantena, thank you so much. That was so stimulating. And I'm going to hand it back over to our co-host, James, who will be taking some of the questions from the chat, and you lovely folks with your hands up. And I will be quiet.
Hi, Jenna.
Jenna, thank you very much.
Thank you, Jenna.
Thank you very much for that, Jenna. That has been a really, really interesting discussion in this past hour. So thank you all for doing that, for discussing. And yes, now we'll take questions from you all. So as I said earlier, to ask your question, you can use the chat. I can see you've written loads of questions in the chat, so we will be reading some of those, or use the raise your hand function, which I can see hands already up. So just to begin, we have a question that was taken from the chat. Alan, would you like to read it yourself, or do you want me to read it for you?
Thanks, thank you, James. No, I'll read it. I may actually need some help with the question, but my thinking is this. Particles and forces are believed to behave in the same predictable ways throughout the universe. In addition, there are the fundamental constants of nature. Now, to me, all of this seems to represent a form of knowledge or information that we write down in the form of mathematics. But if this is correct, where does this knowledge or information reside? Is it within the implicate order or some other, perhaps more causal level of reality? And then how does, for example, the electron access it to behave as it should throughout the universe? Or how is the electron affected by it?
Who wants to try and answer that?
You want me to take it?
Yeah, sure. Go on, Basil.
Okay. First of all, we physicists use a principle, namely the cosmological principle, which assumes that the physics here and now is the physics out there and in the past. That's an assumption we make. And people like Dyson and I think Dirac have actually worried about what happens if the constant, and John Wheeler, what happens if the constants change in time? What happens if the laws of physics change in time? How do we deal with that? So are there laws in physics? Are there, or as David used to say, they are orders. They are the way we order our experiences of the phenomena that is occurring at the moment. So it needn't necessarily be a law in the sense of the old-fashioned judgment, you know, you shall do this or you shall not do that. So it's very much more flexible. Now you talk, you see, as if the electron exists independently of everything. But does it? Or is it just a feature? Is it just an invariant of the totality? In which case, it is just doing what comes naturally. It has no will of its own, and it is just responding, or the invariant is changing in the environment. And therefore, even our knowledge may be changing. So it's not a question of being out there, it's a question of being in here as we're dealing with it at the moment. I don't know whether that answers the question, but that's the way I would try to answer it.
Thank you, Basil. Can I just press you a little bit more on that? Because that certainly answers it in part. But it says it's still this question, is this behavior and the actual, are they forms of knowledge? I mean, is it, does this knowledge exist in the totality? Is that in a sense what the totality is? An aspect of it, just knowledge that governs how everything behaves?
I find the notion of knowledge rather difficult in this context because it's our knowledge, isn't it? Is it the universe's knowledge or is it our knowledge? And therefore it becomes subjective. And therefore if our ideas change, then our knowledge changes.
Can I just try one other, just and I'll leave it. In terms of the behavior, say, of an electron around the atom, is that a form of information?
That's a form of information. No, I would say no. That's our model that we use to try to understand the structure of the atom. But we know that's not the way, that's not a very good model. And that's where quantum mechanics comes in. So have we changed our knowledge? Yes, but we've changed a way of understanding. I think I'd put more like understanding than knowledge.
Maybe I can add,
Oh, please.
I can add a little comment. If you take the point of view, which I like, which considers experience as primary, then what we call matter, including what we call electron and so on, but more generally, is just, let's say, a regularity or a structure within experience. Our experience is structured. It's not chaos. It's ordered. And one particular form of ordering is what we call matter. But we get hypnotized by it and we start thinking that's something out there which really exists, some solid something. It's all based on consciousness, on our experience of the world.
Thank you.
Thank you.
Thank you. Would anyone else like to comment, Emily or Dave? Or we can also move on. All right, great. Thank you so much, Alan, then, for your question. The next question will come from Gurcharan, who's had his hand out for about 15 to 20 minutes now. You're just muted at the moment.
Sorry, the symbol of a hand, yes. Very much enjoyed the whole process. I'll join for the rest. I liked Basil's concept that the best language, something we have to look at is math, but math is almost an artistic proposition of various ways in which we can represent action, relation, and interaction. And that thought can't be mechanical and fully explained. I totally agree. My own approach is from experience, right? Is I think of the world as connected, immersive, interactive, and emergent. So I'm always attracted to these conversations of folding and unfolding as process, and process and experience need to be, in some sense, primary, from which we can make models that are also useful, right? So I wondered in that context a couple things. One, I wonder this little experiment that Yakir et al. Did for the pigeonhole thing that showed that even if things weren't entangled in the beginning, which is usually how entanglement happens, there's some entanglement and then you get separation, right? And the pigeonhole was to say, well, you don't have to entangle at all. You still have correlations that are different, right? That can show that there are influences and structures of that. So the pigeonhole type of exploration was going beyond initial entanglement as a characteristic for the non-local influence, let's call it. So I'm curious if you have any comments, Emily or Basil, about the direction, at least, that the pigeonhole experiments were going. Second, I have a comment to David, which, yes, holding things, opposites together in some space. And for me, it's that's why I kind of reserve the word awareness for it, because awareness for me is, I don't know, kind of an experience where you can both be experiencing the irreducible wholes, which we can now show exist, and the local emergent wholes without the need for collapse or anything. But in that realm, you require what you were saying, you need to have a kind of a randomness, a noise, let's say, but you also have a freedom of choice. And well, I got more, but those are, let me stick with those as a question to Shantena for the intellect deconstructing, but experience being able to hold these opposites as a process in which the sense of self evolves. That's enough.
Thank you, Guru Chana. And who wants to start? There's a lot there, so maybe you can take it in sections. Emily, did you want to start with the first question?
Yeah, so the conclusion I think I draw from the pigeonhole experiment and from other sort of similar delayed choice or entanglement swapping type experiments is that entanglement and non-locality doesn't occur only in space, it also occurs in time. And it's pretty straightforward to see that that must be the case, because you can take spatial non-locality and perform a reference frame transformation to produce what looks like temporal non-locality. And so I think what this kind of effect is showing us is that in the quantum world, we can't really think of the universe as being like a computer which just takes in a state and evolves forward in time. We need to think about laws as applying in a more holistic way all at once to the whole of history. So I view the pigeonhole experiment and these various other delayed choice type experiments as demonstrations of the way in which entanglement and non-locality applies, not just across space, but also across time.
Thank you, absolutely agree.
Basil, do you?
No, I'm not going to add anything. That was a good answer.
Okay, good.
I'll only confuse everybody.
Dave and Shantena, do you want to answer the second half of Guru Charan's question?
Could you remind me of the second half of Guru Charan's?
Do you want to say it again, Guru Charan?
Oh, go ahead, James. You got it.
No, it's better if you do. I didn't write it down.
Okay. Let's see, Shantena. Yes. I guess for you, it would be this idea that I was saying of awareness. Awareness, if experience is primary,
Yeah.
And all the forms and the manner of representations in art, like in math, help us deal with this, collate our experiments and so on. But the idea of awareness for me means the ability that is inherent. Oh, actually, you know what? That phrase that Basil just used of, where was it? I wrote it down because I thought it was good. Oh, yeah. The idea of the invariant of the totality. I like that phrase a lot. Because if there is a wholeness that can't be reduced, and yet it has a correlation in some manner in experience, then how do we think about that? What frame of process might we need? So for me, awareness is that capacity that we experience that does be able to sense local interactions and such that we talk about, parts dancing about and interacting in different ways. And at the same time, simultaneously, temporally, holding the constant immersion of wholes that are irreducible. The ability to do that is maybe a universal thing, but it's certainly definitely one of the characteristics of humans. So I think there's a usefulness to separate awareness from attention, or even local cognition, I would call consciousness, and save, because for the language has to evolve a little bit to be able to hold these profound depths of process that Bohm is pointing to and Basil and others have. So I'll throw that one out.
Yeah, thank you. I totally agree with what you said. I tend to start from, let's say, a very elementary level, in which all these sophisticated things that we do and experience are altogether, let's say, secondary with respect to the fact that we do experience something, that experience happens, that consciousness is. So within that, all kinds of sophisticated things happen. But what I would call primary is this nameless thing, which is we are right now.
Thank you for your answers. It's probably one thing that really attracted me to Kira's book, where he talks about paradox as the way to sniff your way step at a time into the questions that experimentalists and others could do. So thank you.
Thank you.
Sharon, the next question will come from the chat. Gary, you wrote a few questions in the chat, but it was one that you had directed to Emily more specifically that I thought was very good. Would you like to read it out?
Yes, for Emily. So I've been in conversation with Ruth Kastner, who is the originator of the Possibilist transaction interpretation, a variation on the transactional interpretation of John Kramer. And I think she's onto something important, and then it kind of puts the emphasis on transaction all the way from the level of the subatomic structures up to us. And transaction generalizes, I would say, to the process and the action of communication. She differentiates between this realm of possibility, which is, she calls quantum land in her lay person books, and associates that with Bohm's implicate order, and then the world of physical actuality that we detect, that we sense with our physical senses, is the world of that is manifest, and that space-time itself is emergent. That is, there is no space-time in quantum land, right? There is no thingness in quantum land. It's all in the process of unfolding that all these things appear, right? And become actual, right? And I really like the distinction between actuality and reality, where reality is totally possibility, and actuality is physicality, is what we detect on our what Bernardo Kastrup calls our instrument panel, right? We're flying on instruments, right, when we're in our physical actuality, but the reality that's out there, you know, is what's determining the physical actuality that we detect. And that also relates in a way, if you have time, to Ravelli's relational interpretation as well, that Bernardo Kastrup talks about in his idealism. So I don't know, Emily, if that's an reasonable question or not.
Yeah, I really like the transactional interpretation. One thing I really like about it is the symmetry, the fact that it acknowledges that both the past and the future are in some sense equally real and are both having an impact on the present. And I think that's a natural kind of direction to move into once we acknowledge that the standard time evolution picture doesn't seem to be working very well, that we seem to have sort of entanglement in time and a sort of holism, which this symmetric past and future impact picture expresses very nicely. I also really like the fact that the transactional interpretation takes kind of modal structure very seriously, and it really sort of bases the way in which things work on the underlying modal structure of reality. Because I think ultimately scientific theories are about modality. They're about what is possible and what is not possible, and how things tend to behave, and how things can and can't behave. And so I think by kind of taking that really seriously and putting that into the structure of the interpretation, they're getting at something really important, not just about quantum mechanics, but about sort of how science works.
Thank you, Emily, for your answer, and thank you, Gary, for your question. I actually have a follow-up, which may be more directed towards Basil and Dave, which is, so we've talked about briefly Kastrup's analytic idealism, but one name that's popped up a few times during this series is Schelling and Fichte, which they represent the more German idealism. How does that fit in with all the physics we've been talking about?
Well, I'll have to leave it to Basil because I haven't read Schelling and Fichte. So I don't know what approach they take, what points of view they take. But just while I'm saying something here, I would like to come back, if we may at some point, to Emily. And, she's bringing us around to this notion of seeing everything at once and looking at the whole thing at once. And just what this has to do with causality. But I'm sorry that, okay, I'm diverting from the question. I'll go back to Fichte and, Schelling.
No, go on, Dave. We can come back to the Germans.
Yes. Yeah.
Yeah, carry on, Dave.
So the whole at once picture, can this in any way, taking it outside the confines that we usually work in, can it start to break down our idea of what causality is? As in, this can cause that, whereas this is correlated with this, but they can't have a causal relationship because they're cotemporal. So I'm just wondering, if you're opening something that's really interesting here, this all at once view, where it may start to undermine something that we think is really essential to our whole way of thinking.
Yeah, very much so. And so I think in this all at once picture, you would have something a bit more fundamental than causality at the most fundamental level, some sort of bringing about where things in the past would bring about things in the future, but also vice versa. It would be a kind of reciprocal relation. So what we think of causality, I think, would probably emerge within that picture as a kind of perspectival effect, that we would sort of see causal effects in terms of what things we can manipulate and what things we can affect in terms of the way in which we're embedded in this all at once picture. But causality in that sense wouldn't be a sort of fundamental feature of reality. It would be our perspective on the ways in which we can manipulate correlations in various sorts of ways, but it wouldn't be more fundamental than the sort of reciprocal relation between the past and the future.
Thank you, Dave and Emily.
Yes, I suppose I ought to say something, oughtn't I?
If you want, yeah,
I introduced saying at some stage I made the comment that it was Schelling and Fichte that actually helped me along. Now that was in the context of David Bohm, who, as you all know, used to read Hegel almost every day of his life. And I put my nose into Hegel once, and I'm afraid I withdrew it pretty quickly because I could not really get into his spirit. And then one day, someone who'd come from Sao Paulo gave me a little book which suggested that a better way of starting would be to look at Schelling and to also look at Fichte. And the idea there was the emergence of space-time. Now, I think it's Schelling, or it may be Fichte. I'm sorry, it's going back a few years since I read these people. What they were, it was when I was looking, very, very long time ago, when I was looking at Penrose's suggestions that we should have space-time as emergent. And I'd sort of got hooked on the Kantian idea of the space-time being a priori. And I was trying to wonder what that relation was to the emergence. And it wasn't until I began to read Schelling and Fichte that I saw a way out of it. And then I looked at quite a number of works of those two authors, but then I discovered that Weil was very much influenced by Fichte. And again, Weil was really emphasizing the activity again, and the fact that you cannot distinguish between inside a material substance and outside the material substance. And so I then found, of course, that what I'm doing is I'm using Weil's ideas in symmetry breaking, because I'm using his gauge invariance modified in such a way that you get the particle emerging from symmetry breaking. So that's really where I would put Fichte and Schelling coming in influencing me.
very interesting. Thank you for that, Basil. Okay, so we'll move on to another question. We'll go to a physical hand raise, which is Michael's.
Hi. Bohm talked about undivided wholeness. At the fundamental level of nature, he saw it as oneness, the oneness of consciousness. Now, if that is the case, at that fundamental level, it exists in reference only to itself, because there isn't anything else. There's nothing relative about it. So what does that notion of existing in reference only to itself, what does that notion do to the fundamental quantum mechanical concept of contextuality? Doesn't it just obliterate contextuality?
No, because in order to talk about anything, you have to break that wholeness, you have to break that symmetry. Otherwise, we cannot even begin to talk. And the great thing about quantum mechanics is it tells you a way of doing that. And that is, I'm now going to use the wave function approach to explain what I mean. And that means that we can actually take an entangled wave function and we can actually decompose it into individual parts. And then we begin to talk. But to think of the individual parts as giving rise to the wholeness is the wrong way round. That's the point we were trying to make. And by the way, the word undivided universe, that title actually was my idea that we should call it that. So if there's anything untowards with it, I can take the blame rather than David Bohm.
But once you break the symmetry, you have emerged from the fundamental level. You're no longer at the fundamental level of oneness. And okay, so yes, then it's different. Then there is contextuality. But what I'm getting at that fundamental level of oneness, if there's oneness, there's no divisions. It's undivided.
Yes.
And doesn't that notion run counter to the notion of relativeness and contextuality?
No, I don't think it does. And I mean, the interesting thing watching David when he was trying to get to the bottom of this idea was that he almost descended into the Hindu notion of the oneness, where everything went so quiet that nothing occurred at all. And that, I feel, was something that I couldn't tolerate, because in my mind, I've got things going on no matter, all the time, coming out of the oneness, boiling out, attracting my attention so I can talk about these things. Otherwise, if we're going to go to that utter silence, there will be nothing.
Well, just to elaborate on the Hindu notion of this utter silence, it is not absolutely nothing. That is a misinterpretation. All the Hindu rishis say that embedded within that silence is great dynamism. Consciousness moves within itself. It vibrates. And why I am turned on to Bohm is his notion of unfoldment, and foldment. While it's so consistent with the Hindu notion of within this fundamental level of consciousness, this unbounded silence, it's the movement of consciousness within itself. It's vibratory rates, it's sounds, which is a close, and these sounds vibrate, and it's eternally vibrating within this field of consciousness. It's not nothingness. It's wrong to think of this fundamental Hindu state as nothingness. It is consciousness moving within itself.
Oh, thank you very much for that. That makes it much clearer, because for me, the folding, enfolding, and unfolding is the basic notion of quantum processes.
And that I think I am fair in saying that the Hindus would argue that this unfoldment and folding occurs within the fundamental level. Its consciousness eternally vibrates within itself, moves within itself. And I guess to elaborate more, those vibrations is basically are the mantras, the sounds of the Vedic literature. It's these sounds that eternally vibrate within the field of consciousness, which to me links beautifully to folding and unfolding.
Okay.
Thank you. Did anyone else like to build on that or comment?
I'm not sure if I can, but I'll give it a try.
Go on, Dave.
So, wholeness exists only in reference to itself. So I just maybe like to come back to kind of points that we were bringing out. Is wholeness dynamic? You see, and what we mean by wholeness is that something is not bounded internally or externally. It doesn't have limits. But David Bohm talked about undivided wholeness in flowing movement, which is all quite dynamic. So I think it may be true that wholeness in itself exists only in reference to itself, yet it can manifest in certain ways. And Bohm suggested that the human mind is not only a processor, a computer, but that in very subtle states, it could become an antenna, and it could participate in the fundamental movement, not represent it with ideas and so on, but be a participant. And now participation is always something which is alive, which is of the moment. And it doesn't necessarily have a residue. you know, it doesn't necessarily leave a mark. And so then, so this was something that Bohm was very interested in, kind of learning that has no accumulation to it. A learning which is a form of being, and it is of the moment.
How does this address this concept that David just expounded? How does that help to resolve the contradictions, the differences between quantum mechanics and relativity? Can it help create a synthesis?
Well, okay, I have my questions about relativity, because relativity is based on an analysis of a structure of points moving in time. But if we take seriously the notion that there are only processes which are non-local, and something that seems to be a thing is something which is actually recurrent, then the elements that we're talking about are not points. And so then this leaves open the door to taking a fresh look at the Lorentz transformation. Certainly, it must work well on a lot of scales, but maybe at a submicroscopic level, we have room for things to happen. I mean, we can create a lot of different mathematical transformations that leave the light cone invariant, you know, with a Lorentz boost. So I think there's a whole area there that I'm not sure has been explored as nicely as it might be.
Thank you, Michael, for your questions. Very, very interesting. Let's just move on to the next, which will come from Niels.
Okay, I've been listening now for a very long time intently to all these various ideas, and I'm trying to look at, is there any kind of, is it moving in the right direction, or are we just divergent in all our efforts and understanding? One thing that's very important to me is actually we talk about a reality that is what this job is, to find it, what is that reality behind what we see. And I believe Bohm was close to understanding that. And I believe that he died before he was able to tell us what that was. And I've been studying the undivided, the last chapter in the undivided universe many times, and every time I read it, I get slightly different perspective. And things I have, I'm just trying to remember from my mind some of the things that made an impression. He said that it's not stochastic. He's talking about the implicate order. Sorry, all these names I find very difficult to cope with. And so he talks about, I believe he actually concluded that it is deterministic in a sense. And if I look at, I have this transportation model system I developed 30 years ago. And that was a eureka moment, because knowing a little bit about physics and general relativity and quantum mechanics, and I thought, here we got it. This is wholeness, and it's wholeness and reality. And it points straight at I really need much longer to explain this, but this resonates with Basil's idea of the goal that whatever our intentions are, that is goal directed, and that was the first thing I found in my work, was that how can we make any sense of this transportation, that every single individual in this system had his own goal, and how could we find out how that impact on the way he behave, the way he makes decisions, etc. So, but what was the most amazing thing was that it produced, by being goal directed, every participant with the same goal, they helped create what we call a wholeness of reality, where the the implicate order is the causal effect on that. Without actually explaining in detail what it is, what I have found in the past, when I've explained it, people either fall asleep or they don't understand it, and they get angry with you. So, but I'm saying that this I believe is what Bohm's insight on the day that he died. Any comments to that?
Well, can I take it, James?
Of course, go ahead.
Yeah, I'm glad somebody has actually read the final chapter in
several times. Yeah.
Thank you very much. The intention there was to do a second volume. And that was just laying some foundations, some markers that we would have taken up if David had not died when he did. But unfortunately, that never got written. But I don't know where you got the idea from that we said the universe was determinate. That is not what we intended.
No, that was part of what came out of his talk in the last chapter.
No, I wrote that chapter. Please.
Okay.
So you must have some insight which I have not picked up in writing.
Well, in saying it's not stochastic, the only other half of that is determined.
No, it's to do with this non-differentiability of the continuous curves. That was what it was.
Okay.
You can add stochasticity if you want.
Yes.
That's fine, but that was not what we had in mind at that stage. Okay, so I'm the real problem is that was too short, I think. Yes. But what I've been trying to do in my lecture was to fill out some of those ideas, probably not very successfully, but that's what I was trying to do. And I'm trying to write the follow-up book that I hoped he would help with by myself, and it is very difficult. I have great admiration for David. He was a very clear thinker.
Yeah.
That's great. So when are we expecting follow-up then, Basil?
Oh, who knows? If you lot keep distracting me, never.
Well, we want to hear you speak.
I think that what I discovered is extremely important, but it will take, it actually takes a real change of mind to understand that. I will be willing to do a talk, and I think I would like to do it with Ian McGilchrist, because he's into the right hemisphere and the left hemisphere, and what this reality thing relates to the right hemisphere, and that is the one that we as humankind tend to not actually use very much. It is it exists in the sense that we can dip into it if we can meditate and be quiet and try and seek solutions. Then we might get inspiration. And so I could call this an antidote to Kastrup's analytic idealism. I could call this analytic reality. But you may think that I'm just kidding or just.
No. Well, thank you very much, Niels. We should move on just because time is short and we still have one more question to come. So thank you very much, Niels. Jonald, do you want to ask the last question?
Yeah, this question is for Basil. Cool. I remember in your last slide, you said that there's no ontological wave function because everything is already in the algebra. Everything is already in the non-commutative geometry. And when you talk about non-commutative geometry, you're talking about Clifford algebras. And Clifford algebras are based on quaternions. Quaternions, in turn, are a higher form of imaginary numbers. Like instead of just having I, you have I, j, k orthogonal to one another. So these are imaginary axes, basically non-commutative in their interactions. So my first question is, since you've shown that the Dirac equation, the Pauli equation, and the Schrödinger equation are shown in quaternion dynamics. They're shown in Clifford algebras, which are non-commutative, and quaternions, which are a higher form of imaginary axis. Does this, like Penrose used to say, this magical complex number, complex axis has to do with the strangeness in Bohmian mechanics, quaternions in particular, I, j, k, when you interact them. Okay, that's my first question. My second question is, you said that the Bohmian potential arises when something moves. So for example, in the Coriolis effect, when something moves, it sort of produces, in question mark, does the Bohmian potential come out of movement? With Mercury, with the Coriolis effect, and your example there is when a plane moves through the air and it's sort of drafted by the air upwards. That's analogous to a quantum potential acting on the movement of the wings plane. So that's my second question. How is quantum potential, how does if it really arises out of movement, how does it sort of arise out of movement? So that's my second question.
Okay, first question then, what you have not realized is that it's not merely the orthogonal Clifford algebra that is the main source, it is the symplectic Clifford algebra. Now, the symplectic Clifford algebra is something which has very limited literature, even in the mathematics field. The man who really inspired me was Maurice de Gosson, who does a lot of symplectic, he does symplectic geometry, and symplectic geometry brings in new features. It brings in essentially the Heisenberg group.
Yes.
So it's part of the Heisenberg group. It's when you put those two together, the orthogonal and the symplectic Clifford algebra, that you get quantum mechanics appearing. So it's not just the orthogonal. Okay.
Okay.
You have to look at the symplectic structure and see how that relates to the whole thing as well.
But what is it about non-commutative geometry that gives out this strangeness in quantum mechanics? Because you also emphasize that there's something about non-commutative geometry
it's because it's dealing with actions, and in Heisenberg it's dealing with position and momentum. It's dealing with the relation between position and momentum. That if you find the position first and then the momentum, it will be different from measuring the momentum and then finding the position.
Yeah, I understand that. But what is it about at the root cause? There is something in the geometry of the universe that sort of operates on non-commutativity, which is on the classical world, which is there's no AB minus BA.
Well, there is.
That's zero.
No, there is even in classical physics.
Yes, in Coriolis and yeah.
Well, it doesn't necessarily have to be anything fancy like Coriolis. You just do the actions in a different order, like rotating about two axes in a different order. First one, then another, then repeat it with this one first and then the other. And you find that you don't get the same result. So there's something.
A simple way to say that would be try walking through, open a door and walking through. It makes a difference.
So you're pitching my line, Shantena. My line, yes. That's the most obvious one, but this question is trying to get a little bit more deeper, I think. And I'm trying to suggest that it is the dynamics itself which is non-commutative, not just the rotational aspect of it.
Yeah, I was thinking of that because it's a philosophy of mathematics problem.
Yes,
it's quite really hard to think about it.
Oh,
okay, for the second question, how does the Bohmian potential arise out of movement? How does it arise? It's a question mark in your slide.
Yeah, I tried to explain that not all forces. I didn't say it arose as a Coriolis force. I said not all forces are pairwise additive. There are other load of forces, which are these Coriolis type forces, which are due to the kind of force that explains the perihelion shift in Mercury, which you cannot do using Newton's laws of motion.
Yes.
So I'm just pointing. We've got to do a lot more work than what I've done with you in these two sessions. I was just pointing in, look in that direction and you'll see something more general emerging. That's all I was saying.
I see.
Okay,
there's
to do to bring it out.
It's an ongoing project for you.
It's an ongoing project for you. I'm trying, but I can't get the thing across in a meeting like this, which is, got a very general audience, and I've already lost them anyway by trying to be simple.
Okay, thank you, Basil. That's it for me.
Thank you, man, for your question. Unfortunately, time is up, so we can't really take any more questions. I'm really sorry, Matthew, or anyone else wanted to ask a question, but I think we should start closing the session. Just before we go down, I'd just like to go around the panelists and see if you have any takeaways from this past 4 weeks that we've had together. 1 minute each to get something to take away with us. Emily, do you want to start?
Yeah, I think there've been some sort of interesting themes that have emerged, which I would like to pursue further, and I hope others will as well. The sort of this notion of wholeness and of the need to see things all at once rather than a sort of in a reductionist little by little flavor. And the role of time and the way in which we need to come to new conclusions about the way in which we understand time in order to make progress with understanding how physics works. So those are, I think, really important takeaways that I will pursue in my own research, and I hope other people will also pursue as well. And I hope to see more research on that coming out in the future.
Thank you very much, Emily, and it's great to have you with us. Basil.
Yeah, no, I'm just been very interested in the fact that there are still almost everybody listening to what I have to say and what we all have to say. That is an achievement. And the questions are always very interesting. They're not physics, but they're very interesting because they indicate that people are interested, but they just have not had the time to study the things that I've studied, just as I have not had time to study the things that they've studied. So I learn a lot while I go along with the comments that come in from the audience. Thank you very much.
Thank you so much, Basil, and thank you so much for being present at all these events and contributing as much as you can. It's we all appreciate it here. Shantena, you've chaired this first half. Any thoughts?
I'm very grateful. I've loved these conversations. It's my passion to well, just to see how far the mind can go, and then knowing where we must stop. And I always have Lao Tzu in my mind, and it's Tao that can be spoken, it's not Tao. But the speaking is lovely.
Well, thank you so much, Shantena, for that. And thank you so much for all the work you've put into the organization and this first half of Beyond Bohm. And finally, we've got Dave, who's going to be the bridge between this section of Beyond Bohm into the next, which will be on contemplation and creativity. Dave, any comments?
Well, firstly, you know, I wish I could be that bridge. Because in a way, when we do contemplation and creativity, we'll really be talking about something that we don't know about, and we've touched the edges of, you know, which will perhaps, you know, require us to be more tentative than we actually are if we want to say something. What I'd like to bring along is that in my understanding of Bohm's understanding, what is really key to moving forward is a new form of cognition. Our old form of cognition is so valuable, you know, so important and absolutely necessary, where we're talking, where we have knowledge, we have reason, and we work with the two together, and you know, our experience and our mathematics and so on, we work with them together, and we come up with representations, which are always limited, abstractions of reality. So Bohm is suggesting that there's a next step in this game, which is a new approach to a new mode of cognition. And he was looking to a new form of science where mathematics would be an important expression, but it would not be primary. You know, he felt, for example, that what he said was that at the end of his life anyhow, that we'd come to making assumptions because we'd done things the same way for a long time, that that the key to the door was the mathematical key. And he was questioning that, and he was interested then in a new way of processing things and of meeting things. And so so I guess that's in some sense what we'll try and touch on. It'll happen only very peripherally, I think, you know, through art, through questions of creativity, through dialogue and so on. But let me leave you with my favorite Einstein quote, where Einstein, who used this other territory, wrote about it a little bit, called this intuition. He said, "The intuitive mind is a sacred gift. The rational mind is a faithful servant. We've created a society that honors the servant and has forgotten the gift." And that's the box that we're all in, you know, that we're trying to work our way out of in some sense. So I'll leave it there.
Thank you so much, Dave. Thank you so much for being on this panel. Thank you to all the panelists that were here today. Thank you to all the speakers that have spoken throughout this series. And a great thank you to the organizers, Eleanor and Jenna. Yeah, and thank you all for joining us. This has been really great first half. I'm really looking forward to the second half, which will start on the 15th of August. It will be called Beyond Bohm, Science, Order and Creativity, Contemplation and Creativity. So in the past 2 weeks, we've of course explored Bohm's most probably the most influential work, which lies in the world of quantum physics. And in the next part, we will be looking at his philosophical ideas, which cross multiple disciplines with a holistic approach. This sequence of presentation will explore new threads of inquiry inspired by Bohm. So in this section, which starts on the 14th of August, will take form in a series of panel discussions, very similar to what we've done today. And we'll have a grand total of 25 guest presenters who will be looking at creativity in the artist, headed by Hester Reeve, imagination and participation, a Bohm-Barfield nexus, organized by Lee Nicol, transformation and renewal through indigenous dialogue, led by Lee Roy Littlebear, changing consciousness, headed by Dave Schrum, which we know, and finally, dialogue, lineage, and the transmission of participative consciousness, led by Beth Macy, who's here with us today. And of course, we'll have a final panel similar to this one, where we'll all discuss what we've been talking about. And the whole event will be chaired by Lee Nicol. So I really hope to see you then. As always, to contact us, you can use our social media, website, or even email. James@PowerCenter.com to contact me, or Eleanor@PowerCenter.com to contact Eleanor. Thank you again, everyone, for joining us, and we'll see you again soon here at the Power Center.
Thank you, James.
Thank you.
Thank you.
Thank
Thank
you.
you.
Really,
Great
thank you,
again.
Jana.
Thank you
Goodbye
so
all.